So I'm going to report about physical and chemical condition in culturing microalgae. There are 6 physical-chemical parameters. First is the light, second is the pH, third is the aeration or mixing, fourth is the temperature, fifth is the salinity, and sixth is the growth dynamics. For elaborations, I will explain it one by one. Let's start from light. What is light? Light is the source of illumination, whether a natural or artificial light. Microalgae photosynthesize. For example, they assimilate inorganic carbon for conversion into organic matter. It serves as a source of energy which drives this reaction, and in this regard, intensity, spectrum, and photoperiod to be considered. Light intensity plays a big role, but the requirements vary greatly with the culture and the depth of the density of the algal culture. At higher depths and cell concentration, the light intensity must be increased to penetrate through the culture. For example, 1000 lux is suitable for Erlenmeyer flask. From 5,000 to 10,000 is required for larger volumes. Light may be natural or supplied by the fluorescent tubes. Too high light intensity, for example, direct sunlight, small container, close to artificial light, may result to photoinhibition. Also, overheating due to both natural and artificial illumination should be avoided. Fluorescent tubes emitting either in the blue or the red light spectrum should be preferred, as these are the most active portions of the light spectrum for photosynthesis. The duration of the illumination should be minimum of 18 hours of light per day. Although cultivated phytoplankton develop normally under constant illumination. Second is the pH. What is pH? pH is the measure of how acidic or basic the water is. The pH range for most algal species is between 7 and 9, with the optimum range from 8.2 to 8.7. Complete culture collapse due to the disruption of many cellular processes can result from a failure to maintain an acceptable pH. The latter is accomplished by aerating the culture. In the case of high-density algal culture, the addition of the carbon dioxide allows to correct the increased pH, which may reach limiting values up to pH of 9 during algal growth. The third one is the aeration or mixing. What do you mean by aeration or mixing? Aeration or mixing is the introduction of air into a material. Mixing is necessary to prevent sedimentation of the algae. To ensure that all cells of the population are equally exposed to the light and nutrients. To avoid thermal stratification, for example, outdoor cultures, and to improve gas exchange between the culture medium and the air. The latter is of primary importance as the air contains the carbon source for photosynthesis in the form of carbon dioxide. For every dense cultures, the CO2 originating from the air containing of 0.003% carbon dioxide bubbled through the culture is limiting the algal growth, and pure carbon dioxide may be supplemented to the air supply. For example, at the rate of 1% of the volume of air. CO2 addition furthermore buffers the water against pH changes as a result of the CO2 CHO3 balance. Depending on the scale of the culture system, mixing is achieved by stirring daily by hand using test tubes or Erlenmeyer flask. Aerating such as bags, tongs, or using paddle wheels and jet pumps or ponds. It should be noted that not all algal species can tolerate vigorous mixing. Fourth is the temperature. Temperature is the degree or intensity of heat present in a substance or object, especially as expressed according to the comparative scale and shown by a thermometer or perceived by touch. The optimal temperature for phytoplankton cultures generally 20 and 24 degrees Celsius, although this may vary with the composition of the culture medium, the species, and the strain cultured. Most commonly cultured species of microalgae tolerate between 16 and 27 degrees Celsius. Temperature lower than 16 degrees Celsius will slow down growth, whereas those higher than 35 degrees Celsius are lethal for a number of species. If necessary, algal cultures can be cooled by the flow of cold water over the surface of the culture vessel or by controlling the air temperature with refrigerated air conditioning units. Fifth is the salinity. What is salinity? Salinity means that the quality or degree of being saline. Salinity. Marine phytoplankton are extremely tolerant to changes in salinity. Most species grow best at salinity that is slightly lower than that of their native habitat, which is obtained by diluting seawater with tap water. Salinities of 20 to 24 G times L negative 1 have been found to be optimal. And 6 is the growth dynamics. What is growth dynamics? It refers to the changes of the 5 phases of the growth dynamics. Growth dynamics characterized by 5 phases. The first phase is the log or induction phase. In this phase, during which little increase in cell density occurs, is relative along with an algal culture is transferred from a plate to liquid culture. Cultures inoculated with exponentially growing algae have short log phases, which can seriously reduce the time required for upscaling. The log in growth is attributed to be physiological adaptation of the cell metabolism to growth, such as the increase of the levels of enzymes and metabolites involved in cell division and carbon fixation. The second is the exponential phase. During the second phase, the cell density increases as a function of time, p according to the logarithmic function, with c of t and c of 0 being the cell concentration at time t and 0 respectively, and m equals a specific growth rate. The specific growth rate is mainly dependent on the algal species, light intensity, and the temperature. The third one is the phase of declining growth. Cell division slows down when nutrients, light pH, carbon dioxide, or other physical and chemical factors begin to limit growth. The fourth is the stationary phase. In the fourth stage, the limiting factor and the growth rate are balanced, which results the relatively constant cell density. The fifth is the death or crash phase. During the final stage, water quality deteriorates and nutrients are depleted to a level incapable of sustaining the growth. Cell density decreases rapidly and the culture eventually collapses. In practice, culture crashes can be caused by a variety of reasons, including the depletion of a nutrient, oxygen deficiency, overheating, pH disturbance, or contamination. The key to the success of algal production is maintaining all cultures in the exponential phase of growth. Moreover, the nutritional value of the produced algae is inferior once the culture is beyond phase 3 due to reduced digestibility, deficient composition, and possible production of toxic metabolites.